Hi, in this video I'm going to be talking about how to solve some basic equations that involve some higher powers of x, okay, because this is part of our rational exponent and radical unit. First thing I just want to mention, make sure that we get this clear, is that, if I take two numbers and multiply them, they're reciprocals of each other. That means you have 5 over, like perhaps 1, and then if we flip that fraction and it's 1 over 5, we multiply those two together, the 5s would cancel out, and I'd be left with 1. The same thing goes with 1/3 times 3. 1/3 of 3 is 1. And 2/3 times 3 halves, in this case, so numbers on both top and bottom, but the 3's would cancel out and the 2's would cancel out, and I'm basically left with 1 over 1, which is 1. And see, that's important because whenever we get to a problem that involves a higher power of x, like a cubic, okay, there are two solutions, two ways that I could do this on my graphing calculator. Sorry, had to go grab it real quick. Okay, and the basic idea is this. If I can convert things to rational exponent form, I know how to solve them on my graphing calculator, okay? So there are two ways to think about this, okay? If I had an x squared equals 64, I would take the square root of 64. But this is x cubed, which means I need to do the cube root. So two methods I want to teach you, okay? Once I get the value that is raised to the exponent, that would be the x in this case. When I get the thing with the exponent by itself, now I'm ready to get rid of the exponent. How do I get rid of a cube? I cube root. So on my calculator, I could either say x is the cube root of 64. That's one way to think about it. Or what I could do is I could take both sides. Here, let me do it down here instead. X cubed is equal to 64. I could take both sides and raise them to the 1/3 power. Now the reason that I might think about it that way, and I actually prefer this second method, is because when I raise a power to a power, I multiply the exponents. And 3 times 1/3, just like we did up here, 3 times 1/3 is 1. So I get x to the first power is what's remaining. And so on my calculator, the easy way to type it in is just to say I need 64 raised to the, and be careful about parentheses here, it's a fraction, 1/3 power. The answer is 4. If I don't want to do it that way, I have to go through and I have to use the math menu, and I have to either use option 4, which is the cube root button, or I have to type a 3 in and choose this any root, the nth root, right? And we talked about that yesterday. So the cube root of 64, I can also get 4 that way, right? But either way, it's 4 cubed is what I have for 64, right? 4 times 4 times 4 is 64. Over here, the difference between the first problem and this problem is that right now, it's not x to the 5th, it's 1/2 of x to the 5th. And so the thing is, when I look at this problem, the first thing I want to determine is what is being raised to a power. And the only thing being raised to the power is the x. The 1/2 is not being raised to the 5th power. It's just 1/2 times the x to the 5th. So before I go through and do anything involving a 5th root, I need to do something with the 1/2. And I can get rid of that by multiplying both sides by the reciprocal, which is 2 over 1. So if I take the 2 times the 1/2, those things go away, and I'm left with x to the 5th is equal to twice as much as 512, which is 1024. Now I go through on my calculator, and two methods that I can do it. I can either do 5, math menu, and use option 5, which is the nth root. Okay, that's the same thing as saying 5, the 5th root, because 5 is going to go up, whatever you have before this is going to go up in the x sign, remember, of 1024. And I get 4, okay? So x is equal to 4. Or the other way that I can think about it, the option I prefer actually, is to say raise both sides to the 1/5 power, because that takes 5 times 1/5, which gives me x to the 1st. And on my calculator, I can do 1024 raised to the 1/5 power. Use parentheses, you get the 4, right? So x is equal to 4 in this case. Now we come across an interesting thing. See, this is squared. I shouldn't have done squared. Why did I do squared? You know what? Let's change this example. Let's change it to the 4th power. That way it's not a quadratic problem. It's something new, right? 3x to the 4th. Here's the deal. When we work with powers of x, this is an important concept to write down, okay? When we work with powers of x, if I have an even power of x, okay, that would be x squared, x to the 4th, x to the 6th, x to the 8th, x to the 10th, so on and so forth, okay? When I'm working with even powers of x, I need to be careful, because every time I multiply values together, let's say -5 times a -5, wait for the bell to ring 8 times, just a second. Okay, when I multiply two powers together, see, those two together make a positive value, right? A positive 25. And if I added 2 more, those two would cancel out and make a positive. And if I added 2 more, those 2 would cancel out and make a positive, right? So every pair makes a positive. And what that means is whenever we solve x squared equations, like if I said x squared is equal to 16, we said that when we square a root, we have to remember plus or minus. Okay, because of that, x could be a positive or negative 4, because negative 4 times negative 4 equals 16. Well, the same thing goes for 4th and 6th and 8th equations. So when I see an even power, this is extremely important, my answer is going to work like this. Ready? First step first. That 3 isn't being raised to a power, so I need to get rid of it. Okay, a single x to the 4th is equal to 108 divided by 3, which happens to be 36. Okay, now when I do the 4th root, I need to remember that this could be plus or minus. So I'm going to raise both sides to the 1/4 power, and my answer is going to involve a plus or minus, because if they were all negatives, they would have eventually been a negative times a negative times a negative times a negative. That would have made a positive value out of it. Okay, so here we go. 36 raised to the quantity 1/4 power, and the answer is 2.45. But it could also be negative 2.45, because watch what happens. See this? That value, if I raise it to the 4th power, gives me a positive number. Okay? So hopefully that makes sense. When I have even powers, I need to worry about it. Negative powers, the negative doesn't cancel out because you have that oddball negative sign. So you only need to worry about it with even powers of x. Be careful of that. Last problem here. Try to get it before students come in. Okay? See this here? What's being raised to the power? The entire chunk of x minus 2. So I actually already have the thing being cubed by itself. That means I'm already ready to go through and do 1/3 power on each side. This is an odd power, so I'm not going to have to worry about the plus or negative thing. Okay? The x minus 2, that chunk being raised to the 3rd and then being raised to the 1/3, see those two cancel each other out, and I'm left with just the x minus 2 on the left, the chunk of information inside the parentheses. That's equal to negative 14 raised to the 1/3 power. That's going to give me a messy decimal here in a second, but whenever I get that messy decimal, I'm simply going to add 2 to it, and I have my answer. Okay, so x is going to be equal to, ready? Negative 14. I'm going to raise that to the 1/3 power. I'm going to add 2 to it. My answer is negative 0.41. So in other words, let's just check it. Ready? If I took that value, okay, ready? And I subtracted 2. And I go through and I cube it. So I'm going through the original equation. I get the negative 14 I was interested in. So hopefully that makes sense. We'll work on a lot of problems like that here in class tomorrow.